Hi guys, this is a super nerdy video for today. I have been trying to figure out our spring scales and how that helps us understand force. And I learned a lot. I was using the website that I sent you a couple days ago with the spring, how to build your own spring scale. And yeah, this experiment actually is proving some of Newton's laws. And I kind of realized that as I was going through the process. So I'm going to walk you through the process of my learning and show you what I found out. So the thing that the website asks you to do after you build your spring scale is to measure your spring. So I've got my ruler here, and when I measured it, I calculated that it was 2.1 centimeters long. And then it says, go ahead and put weights in it. So what I did is I took quarters, because I have enough of them that I can, add them gradually. So I took 2 quarters and I dropped them in there, and then I remeasured it. And it remeasured at 2.2. And then I put 2 more quarters in and I remeasured it, and it measured 2.3. And I kept going. So like 2 more, 2.4, and then 2 more, 2.5. And I've lost a set of quarters, and then 2.6. So the more weight I added to it, the more this stretched out. And guess what? It's proportional. So yesterday, our question asked us, what's the relationship between the mass of an object and the force needed to slide it across the surface? Well, the force that stretches the spring out, it's the same force, and it's directly related to the amount of weight here. As the weight increases, there's more force being applied. Just like when we pushed it, as we pushed it, more force was applied. More weight, more force, and it's directly proportional, and then you can predict. So what I did was I took these quarters and I put them on my little scale here. I'll turn it on. Set to grams. So I put my quarters on there, and it's 12 grams. So for every 12 grams, it increases. We have a 0.1 difference. And using that, we can do the Hooke's law formula. So like if I'm doing this, right? All right, so I've got Hooke's law up there. And then force equals K times X. So K, I found out, is like the restorative force. So that's the opposite and equal force it takes to push back, for X being the change in distance to the spring. So delta L, if you remember from last year, delta is a change. Delta L is the distance. So you can see over here, I wrote down like the initial length. It's 2.1 centimeters. And then as I added 12 grams each time, the first time I have 2.2 centimeters, 2.3, 2.4, 2.5, 2.6 for every 12 grams that I add. So what I was looking at is the difference, right? X is 0.1 centimeters, and K, all right, I figured out to be 120 grams per centimeter. So what I did there to figure out K is I did rise over run. And this graph is going to be different than your graph. So I'll explain that in just a second. Because I think yesterday when you set up your graph, your independent variable would have been the weight, right? And your effect would have been the force, right? But here it's different. So I'll try and explain that in a second. I have a video for you to watch too from Khan Academy that explains it differently if that trips your trigger. So to figure out K, I took the weight, okay, so the grams, and that was 12 grams, right? And I divided it by the change in centimeters for each time. So it takes 12 grams to move it 0.1 centimeters, right? And so you get this proportional thing. You have a rise, right? 12 grams. Every 12 grams, it goes over 0.1 centimeters. So you get, when you divide that out, you end up with 120 grams for every 1 centimeter that it moves. So that is the restorative force of the spring. Ta-da! And so the force that's being applied to it to move it is 12 grams. So yeah, that's super nerdy. And if that trips your trigger and you really like that stuff, that's cool. But the important takeaway here is that there is an opposite force that brings that spring back into motion. And so when we're talking about Newton's laws, equal and opposite reactions and opposing forces, this is kind of evidence of it. That's proof. Also, another nerdy thing about your science teacher is, yes, this morning at 2 o'clock this morning, I could not sleep because I was trying to figure out the challenge that I gave you yesterday to create something that make the spring opposite, to work like the green springs I was using yesterday so that you can apply a push force. And in my sleep, I figured it out and I woke up and I was super excited because I'm a nerd. So I was overthinking the problem. This is what you do. You take the spring off, you hold it here, and then watch this. This is my applied force. So I can hook it up to here to pull it, right? So I could tie this off and I could pull it, or I could push it using my spring. And so that's kind of what I was thinking of, which brings me to the other thing I was thinking of. So listen, I have a fun experiment for you that has nothing to do with physics and everything to do with chemistry and biology that involves eggs. So this is my new challenge for you today. My new challenge for you today is to dissolve an eggshell using chemicals. So with permission from your parents, if you've got an egg and some vinegar, which by the way is effective at killing germs. I'm not sure its efficiency on the coronavirus, but I use vinegar as a safe at-home cleaner. It's effective at killing all sorts of biological components because it's an acid. So we're going to use an acid and we're going to dissolve eggshells. But I was thinking of this experiment, and then I was thinking of this experiment. Oh, that's how I want to demonstrate it. So the force it takes to push this egg in an opposite direction, push the two little eggs in an opposite direction is, there we go, the same force it takes to compress the spring. Nerd, I know. So that leads me to what we're going to do today. I have 2 eggs, and these 2 eggs are different. One's white, one's brown. So one's a store-bought egg, and the other one we just got from our friends. They have chickens, free range, as close to organic without being certified as you can get. And with our talk about GMOs and stuff like that, I don't know if these are genetically modified chickens, but I'm pretty sure they're factory chickens and they're cooped up and all they do is lay eggs. And I don't know, because the price of these eggs was pretty cheap. And if you take an organic egg from the store, it's almost twice as expensive. So I just want to know about the quality of their shells. So a good way to do that, to know if your chickens are being fed all the right nutrients, you can see how long it takes for the eggshell to dissolve. So my prediction is that this egg will take a shorter amount of time to dissolve. And this egg will take a longer amount of time to dissolve because my guess is these chickens are better fed, taken care of in a more natural way than these chickens. However, I could be completely wrong, and I have a hypothesis if that turns out to be wrong as well. So what I'll do is I'll try and pause the video. I'll go get my ingredients and I will get this project started. All right. Okay, I'm back. So just a safety note about the eggs. It was really obvious I needed to wash the farm egg because it had probably poop on it or mud or something. But also you want to take precautions and wash your other egg too before you handle them. And wash them with just regular soap and water because they can have salmonella on them, which is a bacteria that can kill you. So you don't want to like mess with these eggs and then lick your fingers. And so yeah, wash them with soap and water. All right. And so now what you're going to do is you are going to put the eggs in, do a clear glass because it's much more entertaining. So you put the eggs in clear glass and then you go ahead and you, and this is just regular white distilled vinegar. It's 5% acidity. So that's the thing that kills the germs. But this is also the thing that has a chemical reaction with the chemicals in the shell that will dissolve it. So I'm gonna just fill these up so they just barely cover the egg. Almost there. Hey, sometimes your eggs float. That means something too. I forget what it means. I'm gonna put a little bit in there. Okay, and then this one. Just a smidge more. Okay, all right. And so, holy buckets, there's already bubbles forming. So, what this is doing, and if you remember this from 6th grade science, 8th graders, I don't know if you got this, but it's the same thing like if you take limestone and you put acid on the limestone. Now, how do I know this is limestone? Because these actually have fossils in them. They're sea creatures, right? But my 7th graders will recognize this from our unit studying Earth history. So yeah, they got little sea creatures. And if you take just a little bit of vinegar and you put them on here, they will bubble. And this is the chemical reaction. Oh yeah, cool, bubbles. All right. So what happens is the acid here chemically reacts with the calcium carbonate of the shell and of the shells of the ancient sea creatures in the limestone. And so one of the minerals that chickens need to lay healthy eggs in order to reproduce and successfully survive is to have calcium in their diet. And sometimes they don't have enough calcium, and so they lay thinner shelled eggs, which decreases the chance of them, bringing that egg to term and hatching and thus, whatever. But because they're domesticated, it doesn't matter for the chickens because they'll always have a way to reproduce because we make sure of that. But we take the eggs anyway. They're not for reproducing. We take the eggs to eat them, so the shells don't need to be thick. But that leads to the question, if they're not getting the minerals they need to reproduce successfully, are they not getting the minerals they need to be good for consumption? So what's the quality of the eggs? So that's kind of my question. Or maybe these chickens are like really medically well fed too. So that would be if this takes longer to dissolve, having a thinner shell or having a thicker shell, then that could be that these chickens, although they're not organic, but they're fed like a scientific enhanced diet. So we'll find out. So in the comments section, what I'd like you to do is tell me if you can figure out your spring's force, opposite force, the K. See if you can get a linear line, of your rise over run. And then take pictures. I'll post a new document. Take pictures if you set up your experiment. We'll keep our eye on them over the weekend. So happy Friday. I'm probably not going to post anything Saturday and Sunday, but I might because, we're stuck at home and I'm not going anywhere. So whatever. Anyway, so in the comments, post comments about what you might have learned about Newton's laws and how your spring works. And then in the new document, if you can take pictures of your experiment setup, if you're lucky enough to get to do this, just tell me how it's going. Thanks.